me show you how to do a simple electron configuration. Then I will talk about how to use the periodic table to go ahead and do more practice and more complicated ones. All right, let's say we wanted to identify the location of the 11 electrons of sodium. So we look at the nuclide symbol of sodium. Here it is. This is the atomic number and this is the atomic mass. So remember, this 11 represents the number of protons, but it also represents the number of electrons. So where are the 11 electrons going to go? Now, the rule is that you want to fill the lowest energy levels first. So remember how we said the first shell is lower energy than the second, and the second is lower energy than the third. And remember how we said that the S subshell is lower energy than the P. So if you have more than one subshell in a shell, you always fill the lower energy subshell before you jump into the higher energy subshell. So using the system where you have number, shell number, subshell letter, superscript, then you put shell number, subshell letter, superscript. We're going to do the 11 electrons of sodium. So the first electrons go into the first shell, so we write down a 1. And then there's only an S subshell in the first shell, so we write down an S. How many maximum electrons can fit in there? We said 2 can fit in the S, so we put a superscript of 2. Okay, that accounts for 2 out of the 11. Now we filled the first shell. Can't put any more in the first shell because remember we said the first shell maximum can hold 2 electrons. So now we go into the second shell. So we put a 2. Remember in the second shell there's S and P. And remember how I said you always fill the lower subshell, lower energy subshell before the higher energy. So S would get filled before P. So we write S. Maximum 2 electrons can fit in the S. So we put superscript 2. We're done with the S subshell in the second shell. Now we have to go to the P subshell in the second shell. But between every letter, you have to have a number. So you have to have number, letter, number, always. So we're going to put shell 2 also. You can't write 2S2 and then a P. You have to put the subshell. So it'll always be shell, subshell, cell, subshell. And she sells by the seashore. So shell, subshell, shell, subshell, shell, and then subshell. So now we're in the P subshell, okay? Maximum, how many electrons can you fit in the P subshell? We said 6. So we put the 6 here. Do we have 11 yet? Count the superscript. 6 plus 2 plus 2, that's 10. Can you put any more in the second shell? No. So now we have to go to the third shell. All right. In the third shell, you have the S subshell, the P subshell, and the D subshell. But remember, you have to fill the lowest energy level first. And S is lower energy than P, which is lower energy than D. So we're going to go S. How many electrons are we going to put here? Well, remember, S can hold a maximum of 2, but we only need 11 total electrons for sodium. We already have 10, so you put a 1 here. This is the electron configuration for sodium. All right? Now, what did I say earlier? I said you're going to be learning how to figure out electron configurations just looking at the periodic table. This is what I need you guys to do. These first 2 groups here, the alkali metals and the alkaline earths, we're going to call this the S block. S as in Sam. Okay? The rest of the representative elements, this group over here, there are 6 groups. This is going to be called the P group. So the one that has 2 groups is S. The one that has 6, this is the P group. Okay? All these transition metals, if you count them, there are 10 groups here. This is going to be called the D zone. So S zone, P zone, D zone. And then if you count these inner transition groups, you're going to see that they are 14. So this is the F zone. S, P, D, F. What we're going to do is we're going to use the period number and pretend it's the shell number. That's the technique to use the periodic table. So let's say we wanted to do the electron configuration of sodium using the periodic table. All right, so I'm going to try to do this with you guys. Bring this helium, pretend it's right here next to hydrogen, okay? What you're going to do is you're going to read off the period number as the shell number. And then you're going to read off what zone this is as the subshell letter. So this is 1s2 because you went to two places. 1s2. Then you're done with this first shell. Then you come down here. 2s2. And then 2, and you come over here, p6. 2p6 because there are 6 of them, and this is the p zone. So 1s2, 2s2, 2p6, and then you come over here, 3s, and you stop right where the sodium is, s1. Does that make sense? Let's do another one, okay? Let's do calcium, okay? Calcium, 20, 40. All right, see where calcium is, guys? It's right over here. I need my glasses. I can barely see this. I hope you guys can see this periodic table. If you don't see it really well, just make sure you look at your own, okay? All right, let me get rid of this guy here. Okay, so let's do the same thing, but for calcium, okay? 1s2, 2s2, 2p6, 3s2, all the way over here, 3p6. And then you come around here. What comes after 3p6? You're now 4s2. So this is interesting. Remember how we said the third shell has S, P, and D? Notice that after 3p6, we ended up going to 4s2 because it so happens that the 4s is lower energy than the 3d. So you can say, well, how in the world am I supposed to know that? Follow your periodic table. It's there to guide you, to tell you exactly what comes next. Now, when you get into the D zone, you go period number minus 1, okay? So this is my D zone. This is period 4. So period number minus 1 means that this is 3D. This is the D zone. Period number minus 1. So this is the 5th period. Minus 1, this is 4D. Did you get the idea? When you get into the F zone, it's period number minus 2. F zone, period number minus 2. So there are only 2 F zones. There's this that belongs in period 6, and there's this that belongs in period 7. So when you're in this area here, this is 6 minus 2, so this is 4F, and this over here is 5F. Why is it 5F? Because it's part of period 7. So this is called the lanthanide series because all this comes in right after lanthanum. And this over here is called the actinide series because it comes right after actinum. Okay? I don't remember if I gave you lanthanum and actinum as elements to know, but now I'm going to give them to you. You should know those two because lanthanum and actinum are right here in the transition metals, but they begin the series of these two. So this over here is 4F because it's 6 minus 2. This one down here is 5F because it's 7 minus 2. All right, so putting the calcium electron configuration on the board, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Notice I did not go to 3D. Periodic table told me to jump to 4s2. Okay, so let's do one more together using the D zone here. Let's go all the way to bromine. Okay, let's go ahead and do bromine. All right, bringing the helium over here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now that we're in the D zone, remember period number -1. So this becomes 4 minus 1 is 3. So after 4s2 comes 3d10, all 10 of them. And then we stop at bromine. So we go 4p, 1, 2, 3, 4, 5, 4p5. We stop here. Everything in this group is going to end P5. This group here will all end P4. This last electron, P3, P2, P1. This is all S1. This is all S2. So all elements in the same group have the exact same ending last electron of the electron configuration. So let me write the electron configuration of bromine on the board. Bromine has an atomic number of 35. So 35 electrons. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p5. So that last electron went in at the p5. Notice 4s2 has lower energy than 3d. So 4s has lower energy than 3d. 3d has lower energy than 4p. Okay? Good. All right. I think you should be okay with electron configurations. Honestly, the only way to get really good at this is to just practice. Maybe I'll do one more in the next video so that we can incorporate the F zone, and then we'll start talking orbital diagrams. Okay?